Hi everyone, welcome back. For today we're doing day 10 binary numbers. And this is a new concept that we will be introducing. And thus far, we have dealt with base 10 numbers. And base 10 numbers, like its name suggests, the 10 in base represents the number of permutations that a single number can represent. So in this case, if we say it's base 10, if we break down the permutations the number can represent, we can see that there is 0, 1, 2, 3, 4, 5, all the way to 9. And notice that in this case, if you wish to represent 10, because 10 is not exactly in these 10 representations, so we have to include an additional number to represent the number of states with this. So in this case, notice that the number of representations a base 10 number can represent is based by 10 to the power of n, where n is the number of digits in this case. So it's a number of base 10 digits. So that is for the numbers, the base 10 numbers that we know and love. And in this case, for binary numbers, which are base 2, there's only two representations. So that's 0 and 1. And in this case, similar to what we saw earlier, the number of representations that you can have in a single with one or two numbers, like if n is the number of binary numbers that you have, that will be 2 to the power of n, where n is the number of binary numbers you have, or we call them bits. So in this case, if we wish to represent 2 in binary, in this case, because you can only represent two states, 0 and 1, with one single number, we will have to introduce another number. So in this case, we'll have two numbers. So that will be 1, 0. And notice that in this case, two numbers can represent 4 states. So with two numbers, you can represent 0 to 3, and 3 will be 1, 1. And if we want to represent 4, notice in this case, we have 5 numbers to represent now, 0 to 4. So we will have to add in another digit. So in this case, we'll get 1, 0, 0. So in this case, this is 4. And in this case, with 3 binary numbers, you can represent up to 8 states. So 0 to 7. So this is 4, this is 5, this is 6, and this is 7. So similarly, now we want to represent 8, but 8 is the 9th representation. 0 to 7 is our first to 8 state. 8 is our 9th state. So in this case, we would have to throw in one additional number. And in this case, this would be 8. This would be 9, and this will be 10. So with that, this is a simple crash course of how we would represent base 10 digits in base 2 format. You might be wondering, why would we want to bother with binary numbers then? Like, binary numbers don't seem to be very efficient in representing states. The thing is, our laptops, our computers, like, they use switches to represent numbers. And even our characters that we represent in code, those are really numbers under the hood. And that's because we use transistors for our laptops. So transistors are pretty much switches that have either a 0 or 1 state. So our laptops, our computers had to represent all data with just switches. So how they do it is really representing them in binary. So with these binary numbers, in short, all of our code in Python and even in lower level implementations, Python is written in C, the numbers and the characters, they are all given a specific number, and this number is represented in binary under the hood. So that's pretty much why understanding binary numbers are so important. So with that, let's move on to the actual question itself. In this question, we're given a base 10 integer n, and we have to convert this to a binary number, and then find and print the base 10 integer, denoting the maximum number of consecutive ones in n binary representation. This was quite a handful, but in short, if we're given a number like 125, we have to represent this in binary and count the number of maximum consecutive ones inside this representation and print out the number of consecutive ones that we have. So in this case, because there are 5 consecutive ones in the first part of this representation, we return back 5. So that's pretty much it. So now let's start tackling this question. So on the first line on line, sorry, not really the first line, but it's line 13, HackerRank already generated the code to get the integer from this input over here. So now that we have this input, we have to convert this into a binary representation. And Python has this very nice standard function that converts an integer into a binary representation in string format. So now let's do that. Let's do n binary. This will be of type string, and we will pass in n. And to make it clearer how it looks like, I'll be printing out n binary together with its type, so that you get a better idea of what we get. So type n binary, and let's run this. So as you can see, we get a string like this. In this case, 5. The representation of 5 in binary is 101. But we also see a prefix 0b. The 0b is placed in front of the string so that it's clearer to us that this is a binary number. And you can see that we got back a string. So now, we do not really want the first 2 characters. We already know it is a binary, so we can get rid of that using string slicing. So in this case, if we want the characters from the second index onwards, which is 1, we will just do string slicing on this, and we'll pass in 2 for the starting index, and we don't pass in anything for the end index on the right side of this colon. This tells the string slicer to say, hey, I just want you to start from index 2, slice it all the way to the end of n binary. So sorry, the end of n. Sorry, binary n, yes. So now let's print out the result of n binary. And you can see that this is a string without the 0b prefix that we saw earlier. And now we're finally ready to process this binary for the longest substring of consecutive ones inside this string. So one thing that you might notice is that for a given binary representation, you might have multiple substrings of consecutive ones. So for example, if you look at binary 125, you can see that we have 2 substrings over here. The first substring is from index 0 to index 4, basically the first 5 characters, and that is one final consecutive one of length 1 at the end of the binary representation. So we would have to consider keeping track of whether if a certain digit is part of a substring of ones, and also keep track of another variable that indicates the maximum number of consecutive ones we have thus far. So let's go through the first method of doing that, where we will do a linear scan. We will have 2 variables. The first variable will keep track of the maximum ones consecutive substring, and the second variable will keep track of the current window's consecutive substring. And as we iterate, we would just set the maximum consecutive substrings to the max of itself, as well as the current consecutive ones that we have. So to do that, let's first define the 2 variables. The first variable, let's call it max cons length, and let's call this 0. Let's just assign this to 0. And as well as the current cons length, integer equals to 0 as well. And at this point, we are finally ready to do a linear scan across this n binary string. For character in n binary, let's check whether if the character is equals to 1. And if it is 1, we would increment the current cons length by 1 and set the max cons length to be the max of itself together with the current cons length. If the character is 0, then in this case, we will want to reset the current cons length back to 0. So in this case, we will just do that by assigning this to 0. And at this point, by line 37, we should have the maximum consecutive length inside line 27 assigned to this variable. So let's print this out, and let's test this against some sample test cases. It passed. Let's submit the code. And in this case, this succeeded. And this is the first implementation that we can have to solve this question. You might have more, but these should follow the same thinking process. In this case, the time complexity of this is ON. Notice that we are just doing a linear scan across the n binary. So in this case, the the runtime will be linear with respect to how long this n-binary string is. For the space complexity, we are using a constant number of variables. We're not using recursion. So in this case, the space complexity will be O1. It's constant time. It will scale constantly with respect to the length of n-binary. So that's for the first implementation. For the second implementation, let's explore another way of doing string searching. If we look closely at the question, our job is really to find all of the consecutive ones inside this string, and we check which of these substrings have the longest length. So we can use another tactic called regexes, regular expressions, and we can use the library RE, so import RE. So regular expressions is a technique we can use to perform string matches on a specific string of choice. And we will define a pattern that we will use to search for specific things that we're looking for. So in this case, the pattern that we're looking for is really 1 or consecutive ones after that. So in this case, we can define the regex pattern, and with this regex pattern, we can start performing a regular expression search on this n-binary string. So let me describe this a little bit more in detail. So here is the consecutive 1 pattern. This will have a type of regex pattern, and we can get that by compiling something like this. We are searching for ones, and we want at least one ones or more that is following this one. So this is pretty much the pattern in regular expression. It's quite cryptic. We just placed 1 there, and we also have a plus sign to just tell regex that, hey, I want 1, I want the character 1, and I want all preceding ones that follow after that. We will go more into regular expressions in another exercise, but hopefully this would give you another idea that there is actually another way to do this. So once we're done with this pattern, we can start using this pattern to search for consecutive ones inside n-binary. So now all consecutive ones, this would have a type of list of strings. And similarly, like we discussed, like we need to import the list type from typing because it's not in the standard library. And we can do re.findAll. FindAll is a method that takes in two parameters. So that's a flex one at the end, but we don't have to touch that for now. The first parameter is the regex pattern, or a string format which will be taken as a pattern of what you're trying to find from the string. And the second parameter is the string that you want to perform the pattern search on. So in this case, we will pass in the cons1 pattern, and the second parameter will be n-binary. So to show you what we get, I will print out the all cons1 as well as the type of this all cons1. Okay, so if we run this, all cons1, okay, sorry, I made a typo right there. Let me run this again. And you can see that we get back a list of strings. Yes, it's a list of strings. So now that we have all the consecutive ones inside this list, what we can do is search this all cons1 list and try to figure out which one has the longest length. So to do that, we will just define the longest length integer, set it to 0, and for cons1 in all cons1, we would just set the longest length to be equals to the max of itself together with the length of this current cons1 string inside. And once we're done, we can print this longest length right here. Oh, all cons1. I'm always forgetting the additional s at the back of that variable, but this passes all the test cases. Let's submit this code, and there we go. In this case, the time complexity for find all is on. Under the hood for regular expressions, it will also have to go through the entire string to search for all patterns, all substrings that match this pattern. So understandably, this will be on as well. But on top of that, we are also doing another linear scan over this intermediate list over here. So if we give the list, this list a a length of m. So if we say the length of n binary is n, and the length of intermediate list or cons 1 to be m, then in this case the runtime, understandably with this for loop on line 30 and line 39, this would be on and this would be om. Then in this case the time complexity for this regular expression implementation will be o n plus m. So this is slightly more inefficient compared to the previous implementation that we have. And in this case, the space complexity here will be larger as well, because we are now having an intermediate list that contains all the strings that matches that consecutive ones. So the space complexity will be om as well. If there's more cons ones, then we would use more memory over here to assign that to this intermediate list or cons 1. So hopefully this was helpful. This is the second implementation with regular expressions. We will have another question in these 30 days of code for regular expressions, but hopefully this would be a good precursor to share a little bit more with you, and I hope this was of value to you. If you find this useful, please give us a like and subscribe, and we will see you in the next episode.